Section 9.4 continues along the same theme, except we're doing population proportion instead of mean. So it will be a Z statistic. In this problem, we're testing a claim of color blindness. In a study of red-green color blindness, 500 men and 2,100 women are randomly selected and tested. Among the men, 45 have red-green color blindness. Among the women, 6 have red-green color blindness. And this is based on a USA Today study. Is there sufficient evidence to support the claim that men have a higher rate of red-green color blindness than women? Use a 0.01 significance level. I already started marking on this screen, and basically what I did is gave you the test statistic equation, where P1 would be the proportion of men, which is 0.09. Q1 is 1 minus that amount, or 0.91. P2 would be the proportion of women, and then Q2 would be 1 minus that amount. Let's start from the beginning. Our null hypothesis we're testing is that the proportion of men is equal to the proportion of women who have red-green color blindness. The alternative then would be that they are not equal. From here, we know that alpha is 0.01. We need our test statistic. I'm going to use my calculator to determine that for me. So, let's go to statistic, test, and we are doing a 2-prop z-test. 2 for 2 populations, our 2 sample sets, and it's a proportion z-test. X1 is 45. N1 was 500, that's the men. X2 is 6 out of 2,100. We're testing that they are not equal, and we are going to calculate. Let's see. Let's go down. Oh, our z-score, our test statistic here, is 12.63. Our p-value is 1.53 times 10 to the negative 36. I can stop right there, guys. Our alpha is 0.01. If I were to graph it, I would accept 0.01 area for my error. My p-value is 1.53 times 10 to the negative 36. So alpha is greater than p. Reject the null hypothesis. There is sufficient evidence to suggest that the means are not the same between men and women color blindness.